AI, ML, DL, RL. Okay, let's be honest, it's a total alphabet soup of acronyms, and it can feel pretty overwhelming. But what if I told you there's a really simple way to understand how they all fit together? Well, in this explainer, we're going to do just that. We're breaking down these core concepts to show you the powerful ideas behind the whole AI revolution. So let's jump right in.
So, what is the deal with all these terms, right? Are AI and machine learning just fancy words for the same thing? And where does deep learning fit into all this? It is so easy to get tangled up in the jargon, but I promise the relationship between them is actually super straightforward once you see it. And to help you see it, we're going to use a simple but really powerful metaphor. We're calling it AI's nested dolls. This little mental model is going to help you see exactly how all these pieces click together. Just picture one of those classic Russian dolls. Okay, so the biggest, outermost doll. That's the entire field of artificial intelligence. Now you open it up, and what do you find inside? A smaller doll. That's machine learning. And a lot of the time, inside that one, you'll find an even more specialized doll, deep learning. Each one is a distinct part of the bigger one that holds it. Simple, right? All right, let's start by opening up that first doll. Inside the huge, broad concept of AI, we find the technology that is already shaping our world in, like, a million different ways. Machine learning or just ML.
The key word here, the most important word, is learning. See, traditionally, you'd have to program a computer with these super explicit step-by-step instructions for every single task. Machine learning completely flips that on its head. Instead of feeding it rules, you just feed it data, and it figures out the rules all by itself. It chews on that information, finds the patterns, and gets better and better over time, all without a human having to hand code every little thing.
And you are using ML all day, every day, probably without even thinking about it. That spam filter in your email? Nobody gave it a master list of every spam message in the world. Nope. It learned to spot junk mail by seeing the patterns in millions and millions of examples. And that same powerful idea is behind facial recognition, which learns to identify people by analyzing thousands of images.
And really, at its heart, that's what machine learning is all about. It is a pattern-finding machine. It's this incredibly powerful tool for just sifting through massive amounts of data, finding those hidden connections, and then using what it learned to make really smart predictions about brand new stuff it's never seen before.
Okay, now let's open up the machine learning doll. Nestled inside, we often find something even more powerful: deep learning. And this is where AI starts to get really interesting, because it's mimicking one of the most complex things in the entire known universe. So deep learning is this specialized type of ML that uses structures called neural networks. And yeah, they are directly inspired by the human brain. These networks have tons of layers of these little neurons, which lets them process incredibly complex, messy, unstructured data. And by unstructured, I mean stuff that doesn't fit neatly into a spreadsheet. You know, like the subtleties of human speech, or the meaning of a paragraph, or the millions of pixels in a photograph.
I mean, just think about the most futuristic tech you use. When you talk to Siri or Alexa, that's a deep neural network figuring out the incredibly complex sound waves of your voice. When a self-driving car spots a pedestrian on the road, that's deep learning processing a massive flood of visual data in real time. These are the kinds of super sophisticated jobs where deep learning just blows everything else out of the water.
So the key difference here is all about complexity. By using that multi-layered, brain-like structure, deep learning can find these unbelievably subtle and abstract patterns in language and images and sound that other methods would just completely miss. Okay, so let's just put them side by side for a second to really lock this in. You've got machine learning, the big idea of learning from data to spot patterns. Perfect for stuff like spam filters. And then you have deep learning, a more advanced type of ML that uses those brain-like neural networks to crush much more complex jobs, like actually understanding human speech. Okay, so we've seen how AI, ML, and DL are all nested inside each other. But there's another really important concept that works a little differently. It's called reinforcement learning, or RL. Now, this isn't another doll in the set. Think of it as a completely different way to learn.
With reinforcement learning, the AI learns by doing. Imagine a little piece of software, we call it an agent, and you drop it into a virtual world, like a video game. It learns through pure trial and error. It takes an action, and then it gets feedback, a reward if it did something good, a penalty if it did something bad. And its whole goal is just to figure out the best possible strategy to get the most rewards it can over time.
This is exactly how an AI can learn to play a super complex game better than any human.
It just plays millions of games against itself, getting little rewards for moves that lead to a win and penalties for moves that lead to a loss. It just keeps tweaking its strategy over and over, and the very same process can teach a robot how to walk, as it tries out different movements to figure out the most stable and efficient way to get from A to B. So the heart of reinforcement learning is exploration. It's not about analyzing a giant data set that you give it. It's about actively experimenting in its world, learning directly from what happens when it does things, and discovering brand new and often totally surprising ways to win.
Whew. Okay, we have covered a lot of ground, from nested dolls to learning by doing. So now let's bring it all back together and create one single, super clear picture of how these amazing technologies all relate to each other.
And here it is. This is the ultimate cheat sheet. Machine learning is our pattern finder. Deep learning, a super-powered type of ML, uses those brain-like structures to handle huge complexity. And reinforcement learning is our explorer, finding the best strategies through action and feedback. See? They're not competing ideas at all. They're just different, complementary tools in the massive toolkit of modern AI.
So, there you have it, the whole alphabet soup of AI. Totally demystified. From recognizing patterns, to brain-like networks, to just learning by doing, you now get the core ideas that are driving this incredible technological revolution. And as these tools get even more powerful, the possibilities, well, they're truly endless. Which leaves us with one huge question. What are we going to teach them to do next?